Hello dear students, welcome to my channel. Today we are going to discuss the alcohol phenol ether and the chemical reactions of alcohol. We are already on the reaction of ROH bond, right? In this reaction we are going to discuss the part known as dehydration. Okay, dehydration. The dehydration. Dehydration can be done by excess H2SO4. Okay, so it is basically two types which we have already discussed. When alcohol is in excess and H2SO4 is added to it. When alcohol is in excess and H2SO4 is added to it as a dehydrating agent, 140 degrees Celsius temperature. Then the formation of ether is done. Let me remind you again, the formation of ether is here. So this reaction goes like that. ROH, this is your alcohol added to H2SO4. Here alcohol is in excess. Okay, at 140 degrees Celsius, first we have to treat it with 100 degree to 110 degrees Celsius. It will form RHSO4 and water will be removed. Then this RHSO4 treated with again ROH at temperature 140 degrees Celsius. It will form ether, ROR plus H2SO4 will be removed. This was the last reaction we have done in last class. You can write down again. If you are new in channel, subscribe right now. You can use R as a C2H5 and write down some example related to it. Use R as a C2H5 and write down one example related to it. The next reaction which we are going to discuss, which is the starting of this session, is when H2SO4 is in excess. When H2SO4 is in excess, the temperature will be 170 degrees Celsius. Then what we have to do? Alcohol C2H5OH is treated with H2SO4 at temperature 100 to 110 degrees Celsius. It will give C2H5 HSO4 ethyl hydrogen sulfate. The name of this compound is ethyl hydrogen sulfate H2O. Then again C2H5 HSO4 is treated with C2H5OH or just by heating at 170 degrees Celsius. It will automatically give C2H4, that is ethene plus H2SO4. So this is the reaction and dehydrated is done here. Okay. So remember that the next reaction which we are going to discuss is rearrangement during dehydration. Very important reactions which we are going to discuss here. Suppose we have 3,3-dimethyl butane CH3, C, CH, CH3. Here it is OH, or you can CH3 here, CH3 here. Here will be OH. So it is 3,3-dimethyl 2-butanol or butanol. Okay. At temperature 85 degrees Celsius, HPPO4 presence में heat करने पर it will give mixture which is CH3, C double bond C, CH3, CH3. That is the type of ethene, right? And then we have another mixture formed with it, CH3, double bond C, CH3, C, CH3, H, CH. So this is the compound known as 2,3-dimethyl butene, and due to rearrangement, it is also possible 2,3-dimethyl but Okay, so these are the mixture formations. The next reaction which we are going to discuss of alcohol, when vapors of alcohol are passed over heated aluminate, heated alumina, it means L2O3 or thoria. Thoria is THO2. Let's discuss this reaction first. At 1 or 250 degrees Celsius, ether is formed. In this reaction at 250 degrees Celsius, what will be the form? Ether. Suppose ROH is here, treated with ROH, two molecules of ROH in the presence of L2O3, temperature 250 degrees Celsius. It will directly give ROR plus H. Okay. So R can be C2H5OH. Write down the example related to it. It will form C2H5O C2H5. At 250 degrees Celsius in the presence of L2O3 plus water molecule. So this is the reaction you can count. Okay. The next reaction you can write down if there is a mixture present like CH3OH. Second example, CH3OH is treated with C2H5OH. You must be confused what will be the formation. The formation will be CH3O CH3, right, plus CH3O C2H5 plus C2H5O C2H5. So there will be a mixture of three type of ether and the water molecule will be removed. So this is the reaction goes like that. Okay. The next reaction which we are going to discuss in this at 350 degrees Celsius, at 350 degrees Celsius, alkane is formed. In the same reaction, the 350 degrees Celsius, alkane is formed. For example, C2H5OH in the presence of L2O3, not 250, 350 degrees Celsius, it will form alkene plus water molecule. Okay. Reaction occur. If the same reaction occur, which is also known as dehydrogenation, dehydrogenation. In this, the copper is at 300 degrees Celsius. We have to react. Okay. So it can be used as it is a test of primary, secondary, and tertiary alcohols. Why? Because different product will be formed here. Different products will be formed here in case of primary, secondary, and tertiary. So what we have to do in this reaction, suppose we have primary alcohol RCH2OH. Okay. It is treated with copper 100 degrees Celsius. It will form RCHO aldehyde plus H2 gas removed, H2 gas rolled. Okay. In case of 1 degree, okay, this is 1 degree primary. If there is 2 degree, that is RCH2OH R is treated with copper 100 degrees Celsius, it will form ketone. It will form ketone and H2 gas will be removed. So there will be a formation of ketone here from alcohol to ketone. And when there is 3 degree, suppose RCOH R, okay, 3 degree, this is tertiary. Then tertiary is treated with Cu 100 degrees Celsius. The temperature must be raised during the reaction. The temperature will be 300 basically, not 100 I think. 300 degrees Celsius. You have to write down 300 degrees Celsius. So in this reaction, 300 degrees Celsius, it will form RC double bond CH2 R. So alkene will be formed plus water molecule will be removed during the reaction. Okay. The next reaction which we are going to discuss is oxidation, very important part of the reaction. Oxidation of alcohol. आइए start करते हैं. So oxidation is a test of different alcohols like primary, secondary, tertiary, because of the different products. Same we have done in last. So primary alcohol, when reacts with K2Cr2O7 or KMnO4, reacts with KMnO4 or K2Cr2O7, it will give same number of carbon atoms. It will give same number of carbon atoms in the product. How come? Let's start with the reaction. When primary alcohol is oxidized, it will give same number of carbon atoms in product. Suppose you have RCH2OH is treated with acidic KMnO4. The water molecule will be removed and the RCHO will be formed, and further oxidation will give RCOOH. Okay. Further oxidation give RCOOH. So this is the same number. Okay. You can write down example in terms of CH3, CH2, OH. It will form CH3, CH2. What will be the formation? Acetic acid, COOH. So here 2 carbons and the result also 2 carbons. Okay. In secondary alcohol, when we are talking about secondary alcohols, the product will be ketone. The product will be ketone. Suppose this is your secondary alcohol. Okay. Is treated with K2Cr2O7, treated with K2Cr2O7 or Cr2O3, or you can use other oxidation agents also, like a strong oxidizing agent like HNO3 also can be used. So it will form ketone first, RC double bond O R, and further oxidation give RCOH, RCOOH plus CO2, S liberate plus water molecule. Okay, so you can write down the example. Suppose you have CHOH, CH3 is treated with K2Cr2O7. It will form CH3, C double bond O CH3, and further oxidation give CH3 C double OH plus CO2 plus H2. So this is the reaction.